Howdy, howdy, howdy.
Hey everyone, thanks for joining us. So we are here to talk about how to stop reacting to equipment failures and start staying ahead of them. So today we will dive into strategies like root cause analysis, failure modes, effects analysis, real-time diagnostics to help you eliminate defects and strengthen your PM programs.
That's right.
Before we dive into all that though, let's talk about a little webinar housekeeping items. Okay. Oh,
Well,
can we go
meet
back
us
one
first.
slide?
Remember, we changed
Oh, we
our
did.
our,
Okay.
our setup here.
um,
It's very different than last time, guys. So if you
yes.
come to our webinars a lot, I think there's some 400 of you. We did change the formatting a little bit just to be a little more easy on the eyes. Well, Missa did.
Yes.
Missa
Okay.
changed.
So let's get into introducing us, the speakers. So my name is Amissa Giddens. I'm the Senior Marketing Manager here at Upkeep. I've been here for a little over 3 years. And in December of 2023, I got my CMRP, which is Certified Maintenance and Reliability Professional certification. I do want to throw a little plug for Reliability X because I took their courses and that's how I was able to get that certification. I also read Ramesh Jalati's book about maintenance and reliability best practices, and that's essentially how I was able to gain the knowledge to be able to get that certification. So a little plug for them, Reliability X. If you're interested in more resources, they're a good company to go to for that. And then we have our main speaker, Brian. Brian, do you want to introduce yourself?
Sure. Hi, everyone. I'm Brian. I am the head of partnerships here at Upkeep, but I'm more maintenance and reliability professional. I've been turning wrenches for the last 20 years. I've been a maintenance manager, director of maintenance and reliability. I've managed 200 million in assets. I was in the Navy as a wrench turner. I love all things maintenance and reliability. And that's enough about me.
Sweet. Okay.
Ready?
Now let's get into some webinar
There we
housekeeping.
go. Ooh, Chris Wilson,
Um,
Beltsville, Maryland, right down
yeah.
the road from me.
So you guys are used to this, I can tell, because you're already saying where you're joining us from, but where are you joining us from? Type your answer in the chat. So using the chat, it looks like a lot of you are already using it. So great, looks like you're familiar. Asking questions. So we will have time at the end of the webinar for Q&A. So there is a little questions feature down in the bottom corner. It's a little circle with a question mark on it. If you have specific questions you want answered throughout this webinar, then post them in there, because then it's easier for me to sort through and find the questions versus if you put them in the chat, sometimes it can be hard to scroll back and try to find and answer those. So use the question feature when you have something really important you want answered. All right, where's everyone? Oh,
I'm seeing a lot. I saw Baltimore, which is an hour from me. I mean, Kentucky.
It looks like Al is from Brookings, Oregon, which is over kind of on the coast, southwest coast area from where I'm at in Eugene, Oregon. So we got some
Nice.
Oregonians here.
Always. You know, what's sad, I got a message from our good friend Cody Krieger. He's traveling. He will not be at this webinar. It's the first one he's missed in like 2 years.
And he's in Southern Oregon. He's in Grand Pass. So
you guys don't know Cody, follow him. He's great. Let's see. Jersey, close to me. We got 10 of Tennessee, Colorado. I'll be in Colorado next week, actually. Hercules Industries. Wait.
Saudi Arabia.
Hercules as in like hydraulic Hercules company that does hydraulics? Maybe. We'll see. Uganda, awesome. North Carolina. Oh, okay. HVAC. Gotcha.
Florida, North Carolina, Nevada.
Saudi.
South
Greenville.
Carolina.
I got a lot of friends in Greenville. Ben, wait, is that Ben from Digital Thinker? Let's see if I'm right. He's typing in there. It's me. Ben, what's up, man? Ben and I got to hang out at Reliable Plant a few weeks ago.
Oh, nice.
Great dude.
Yeah.
Okay.
All right. Yeah. Well, thank you all for joining us. Like, it always warms my heart to see how many people we have attend from all over the United States and beyond.
Yeah.
So we really, really do appreciate you being here.
Oh, one more shout out, one more plug. Ahmed Bashir is in here. He's a great partner of Upkeep. He helps us tremendously with TMCC. So Ahmed, glad to have you here. All right. Ready, Amissa?
Yeah.
Okay. Go ahead.
All right. So today's agenda. First, we're going to talk about defining objectives and scope. And keep in mind, this is all in relation to preventative maintenance and elevating what you're doing with your preventative maintenance strategies. So first thing we're going to go into is define objectives and scope. We're going to talk about collecting and analyzing data, identifying critical failure modes, implementing defect elimination, how to develop PM tasks. We're going to touch on condition-based maintenance because that's a way to elevate your preventive maintenance program. We're talking about creating a feedback loop, training and involving your team, and then monitoring and reviewing preventive maintenance performance. And then, of course, like we usually do, we'll wrap up with a Q&A session. Also, throughout the webinar, we are going to have interactive questions to engage with you. So when we get on those slides, we're going to ask you a question, and we want you to answer in the chat, and we're going to read out and talk about some of your answers.
So as I always say with these topics, these are big topics. There's a lot that goes into each individual topic. And I just want everybody to know, just like all the webinars, it would be a rabbit hole and days of information for us to in-depthly go through every single aspect of every single one of these things. So just remember, these are high level. There's a lot that goes into this. We're going to touch on the high points and try to provide some context surrounding those high points. So just keep that in mind. So if there's something that's not in here you think should be in here, we probably know, but we were probably touching on just the higher position here to get everybody's mind shaken up and thinking about how these things function. Okay, first one, right? We're going to define, as it pertains to building a preventive maintenance strategy, we're going to define our scope, our objectives and our scope. What do we want as a business? What are our goals? www.company.com, goals and vision, right? What is that? And how does it pertain to what we do as maintenance professionals, right? So what do we want to do? Do we want to have lower downtime? Do we want to extend our useful life of machines? Do we want to lower our maintenance costs, maybe from manpower constraints, from using contractors, like all these different things, right? And then, of course, we always want to improve safety and compliance. But keep this in mind. If you improve your preventive maintenance strategy, right, and you become a more reliable function of your department, you will inherently become safer and more compliant. Maintenance is inherently unsafe. So the less work you're doing, the less risk there is. And 60+% of current maintenance activities at most organizations are non-value adding, meaning you don't need to do them at all. So that's why we're going to define our objectives and scope. What do we want? So we're going to identify critical equipment, right? We're going to go through, we're going to go, wait, these things are the biggest impact to our immediate area, our business, our output, our capacity, our customer fulfillment. We got to understand those things. What are our maintenance boundaries? Meaning, what should we do and what should we outsource? What should we not do? Do we have the skill sets? Do we have the tooling? Do we have the time? Do we have all these things to do different types of maintenance? So we understand what we're going to do and what we're not going to do. And then, of course, team responsibility. No one wants to be a part of a team where they don't know what they're doing or why they should be doing it, and if it even matters, right? So we want to make sure that we define team responsibilities. The most important thing you can do with team responsibility is create a RACI chart. Responsibility, accountability, consult, and inform. That chart will help you lay out how each individual function interacts with a certain process. Keep that in mind, very important. And then your implementation timeline. Stage gate the process. So if you have the things you want to do and you've established who's going to do what, stage gate the process, meaning set the first goal and you don't move on to the second goal until the first goal is complete in your timeline for implementation. And then you go progressively from there until you've achieved your goals, meaning all of the individual ones are complete. So super important. Okay, collect and analyze your data. Remember, we're talking about building a preventive maintenance strategy. So we're assuming to a point that you have some form of preventive maintenance happening currently. So that's why we want to define our scope, make sure we're in alignment with the business and all of our goals and values and the things that we want to do. Then we're going to collect the information that we do have to help us make further informed decisions into the next step. So what's our failure history? Everybody in this chat has a machine or a line or a system or a system of components at their facilities that they would call a bad actor, something that's eating your lunch every single day. Let's start with those things. Let's look at that history. Maybe it's not documented, maybe it is. If it's not documented, Get out on the shop floor and start talking to people about what's occurring, why things are happening, what do they think, what do they believe. It's the best place to start. People who interact and touch the machines every single day. And then if you do have information, we go to our maintenance records. Let's jump through our CMMS. Let's see what kind of work order types we've been dealing with. Are they corrective? Are they reactive? Are they preventive? Are they safety inspections? What kind of work are we doing? And then let's look at the instances of failure, the mean time. How often are these failures occurring? Okay, that's an obvious one. And then, of course, we look at our OEM recommendations. What should we be paying attention to as it pertains to building our preventive maintenance strategy? Now, those of you who follow our webinars a lot, you will know that I always say OEM recommendations is a double-edged sword. You're either going to get too much to over-maintain the machine and in effect to sell spare parts from the manufacturer, or you're going to have a very low amount of interaction prescribed for the machine in order to sell service. So there's a happy median. Take that OEM recommendation, but also look at your current, past information and contextual information of the people that are experiencing the machines every single day, and then look at that data to help building this strategy moving forward. And then, I don't know if I read the quote from the last one, but I forgot. Quality data collection analysis forms the foundation of effective preventive maintenance strategies. We got to know where we are to know where we need to go. Okay, go ahead, Amissa.
All right. So first question, guys. What's your biggest challenge in preventative maintenance today? So share your thoughts in the chat and we will discuss some of them.
It can be anything. It can be technology, it can be leadership, it can be manpower, it can be spare parts, it can be contractors, it could be anything. People ignore. That does happen. People do ignore preventive maintenance. No one wants to document it and take ownership. Ooh, we got a leadership problem there. We should be connecting those people to why it's so valuable.
Asset data accuracy.
Yeah. Leadership, ownership, huge one, Nathan. Scheduling, another huge one. If you guys know me, I beat a dead horse with scheduling. Amissa, are you noticing a trend that we see a lot?
Yeah. Yep.
Ineffective PM strategies. Mike, very intuitive. You should think about that more. Start looking at those PMs. What's adding value? What's not? If it's not adding value, get rid of it.
It is like no use of CMMS. It would be fairly difficult to do an effective preventative maintenance program without a CMMS because then you're not going to be able to collect that data.
You can. The data is just, it's tough. It's much harder, right?
Yeah.
But I will say, I've been a part of and I've talked to a lot of companies that do not have a CMMS and they have a pretty well-functioning maintenance program. But they also have highly tenured skilled technicians. They have people who own the work that they're doing. They have leadership that enables that work to be completed and removes barriers for them. So it's a unicorn, but it does exist.
Yeah.
Okay, no CMMS. Maybe give us a shout there, Aaron. Smith, same thing. Everything on paper. You might want to talk to a miss after this.
Over maintaining. That's one that is like, I like that one because, like you said, especially if you're doing the OEM recommendations, that can happen a lot.
Yeah. Yeah. The over maintaining is a huge one, right? It's I mean, look, the more we touch things, the more risk we involve with that machine. And I said this before, we are the biggest variable. See my hand? I touch machines every single day. I love it. It's my favorite thing in the whole world. But we don't want to do it too much. All right. Ready?
Yep. Let's go.
All right. Okay. Let's identify critical failure modes or mechanisms, right? What are things that are going to lead up to a potential failure? How do we uncover them? What do we do, right? So we want to identify potential failure mechanisms. Is something vibrating? Do I hear a noise? Is something hot? Is something not operating or starting correctly? Is something flopping around? Is this loose? Is this the wrong fastener, right? So start looking at the failure mechanisms. And then we want to prioritize them based on the risk. What is the risk associated with allowing that failure mechanism to progress into a failure mode or a complete critical failure, right? What is the risk associated with that? What are the indicators that determine that failure is present? I mean, that can be a lot of things. So, I mean, insert whatever that is pertaining to your organization. Rank by frequency and severity. So that's essentially the core of failure modes and effects analysis. We want to know how severe is it? What's the occurrence? And how easy is it to detect? So if something is really hard to detect and it has a high severity, well, we might want to employ some other tools, maybe some condition monitoring tools, things that are going to be able to monitor that thing and its nuanced detection capacity, right? So keep that in mind: severity, occurrence, detection. We want to know what's the impact? What's it going to do? How often does it happen? And how hard is it to know when it's going to happen? Super, super important. Like I said, there's a book written on every single one of these things in here. We don't have the time to talk about all that stuff. Just want to get your mind moving on this. Super, super important. You want to identify failure modes. Every PM task and strategy should be directed at some form of failure mode. And if you don't know the failure mode, direct it at the risk associated with whatever it is. If you don't know the exact failure mode, I know this machine is extremely critical. I know that the severity of a failure here is going to be a big problem. So I need to start analyzing it and understanding what's going on so that I can direct preventive maintenance tasks at this thing to uncover potential risk. And then understanding critical failure modes is essential to developing targeted preventive maintenance strategies. Key word in there is targeted. We don't do maintenance to do maintenance. You cannot maintain your way to reliability. It does not work that way. You can maintain your way to inherent reliability. I take that back, but you cannot increase the reliability. Excuse me. Okay, as I alluded to, defect elimination, my favorite thing. Every preventive maintenance strategy I build incorporates defect elimination techniques and strategies. It's the only way to get away or to get ahead. So we want to start talking about design improvements. If you can't maintain something to its inherent design reliability because of something that has to be changed fundamentally from a design or an engineering standpoint, change it. That's the best way to get ahead there. Change it. Okay. Process modifications. This is a huge one. The tasks that you write to interact with your machines, whether proactively, preventively, or correctively, need to be in line with a strategy to reduce variability. You want to make sure that the work you're doing is precise and is not inducing human variability into the process. Component upgrades, same kind of thing as design improvements. Say we have a bearing that has a certain rating shield on it, to protect it's a ball bearing. Has a certain shield, right? And we're using it outside of its design context. We don't need to change everything. The shaft's good, the drive's good, all that's good. It's just this one bearing is giving us a fit. Maybe we want to upgrade that bearing to reflect the appropriate seal design for the context and environment that it's being worked in. Okay. And then this is a huge, huge, huge one. Operator training. Many of you, I'm sure, are a part of organizations that have operators that tear down and set up their machines, whether in the morning or at night, or if you're doing a product run changeover where the operators have to physically manipulate the machine to get it to do something else, right? Or maybe you work in SQF and GMP environments where you have to do tear down and sanitize and cleans in the middle of the night. That involves people taking your machines apart and putting them back together. The majority of issues at startup and shutdown are from those setups. It's because they do not have proper SOPs, standard operating procedures, written with pictures and defined outcomes that should show the operator or anybody that walks in there how to set up this machine effectively and what to do in those certain circumstances. You must have SOPs for setting up and tearing down and changing over machines. So important. It will eliminate so much of your headaches. It's a low-hanging fruit. I know people don't like that word, but it actually is. You can eliminate so much shit by just setting up machines correctly from an operator standpoint. Okay, implementation process. We want to identify the root causes, of course. We want to develop solutions, of course. We want to say, hey, this thing's eating our lunch. What do we have to do? I'm going to bring people into the process. Hey, operator, what do you see? Hey, maintenance person, what do you see? Hey, safety manager, what do you see? Hey, quality department, what are you seeing? So we can get a 360 holistic understanding of these problems so that we can have tailored solutions. And of course, we're going to test and validate. I've had so many problems that I wanted to solve where I didn't really have all the information I needed, but I worked with the team internally, got the buy-in, and then we took a risk-based approach at testing and validating these remedies, right? Sometimes they work, sometimes they didn't. But the fact is we're trying to eliminate defects. And then implement and monitor, of course. If it works, start doing it, track it. You want to make sure it's sustainable and scalable in the long run. And you may uncover other issues that you fix one and you uncover another one by one being fixed. Happens all the time. Eliminating defects at their source is more effective than repeatedly treating systems. My favorite saying in the whole world is fixed forever instead of forever fixing. That comes from defect elimination. How are we doing on time, Miss? Are we doing okay?
Yep, we got plenty of time.
Cool. Awesome. All right. Developing your preventive maintenance tasks. I think, what was it? Was it last month or the month before, Missa? I did a whole entire webinar on preventive maintenance task creation. And it was great. It had a huge turnout and it laid out exactly how to write tasks in defined contexts for all different things. So we want to make sure that we are regularly inspecting our equipment. That's visual. That's a walk around. That's your ears, your eyes, your nose. We're listening, we're touching, we're feeling, we're understanding, right? Lubrication schedules are huge. You want cost benefit, implement a lubrication route that is concise. Component replacements. If you know of useful life items that need to be changed out, then make sure that's established. Make sure you have your changeout schedules in. And speaking on defect elimination, if that changeout is associated with a particular thing failing because of a failure mode that you can eliminate through a design improvement or a component improvement, do that. Calibrations and procedures. This is kind of goes in line with operators setting up and tearing down machines or doing changeovers. We've got to make sure we have checks and balances in place, that we can accurately walk up to a machine and understand its calibration procedures, how it should run, what it should be doing, and know those things. So review manufacturer guidelines. Again, we talked about that. There's some do's and don'ts there. Historical failure data, we know about that one. Optimal frequencies is a big one. We want to do things just before failure, not too early, and of course, not too late. Now, there is nuance there. I'm not going to sit there and tell you that everything I've ever done is like perfect right before failure. We got it out of there and everything was perfect. It doesn't always work that way. But what you don't want to do is you don't want to change things so premature that you're not getting the useful life or cost benefit out of that component. And then conversely, of course, you don't want it to go to failure because now you have all the implications associated with failure on top of also changing that thing. And then document your detailed procedures. Use your CMMS. Use whatever you use to track the things that you've done, the types of tasks, what kind of schedules are you doing, what components did you replace, what procedures are in there. All of that should be concise. And if you haven't, please go and find our webinar on preventive or on our preventive maintenance task creation and watch it. Very, very good one. We had a lot of engagement there. Well-defined preventive maintenance tasks are the building blocks of a successful maintenance program. Facts. You need to know what to do. And you need to know what good looks like and ultimately what bad looks like and have a concise direction to perform those tasks. Okay, go ahead, Amissa.
Yep. Okay. So we have another question, and I did post the link to that webinar Brian was just referring to about creating preventative maintenance tasks in the chat. So if you're interested in watching that, there's a link to it. All right. So another question. Do you currently use any condition-based monitoring tools? So share your experience in the chat, and we're going to talk about your responses.
Prashant says yes, ... What is that? What's the ... mean?
If we're saying yes, then do you mind elaborating a little bit? Like, what kind of tools are you using? Or are you using sensors? Or are you manually monitoring conditions of your assets?
That's totally acceptable as well.
Yeah.
Let's see. No, lots of no's.
We got a lot of yeses and we have a lot of no's.
Online vibration and temperature.
Okay.
Temperature, vibration. They have a predictive maintenance department that offers vibration monitoring. Vibration. Lots of vibration.
Manual, vibration, and thermal.
Good. Air quality. Lots of good ones here. Oil analysis is a great one. If you guys don't know who Sonia Mathura and Rich Wurzbeck are, you should check them out. They are lubrication dynamos. Ooh, Dan's got motion amplification as well. Wow, you guys must have a big budget over there. Oil analysis. Yeah. So a lot of good stuff here, guys. Good. Hopefully it is providing value for you, but just remember, don't lose sight of the things that are the most important which are your planning, your scheduling, is understanding the context surrounding all this great technology and how it impacts your business and ultimately your workers, right? Cool.
Right.
All right. Oh, this is what I missed something?
Oh, you were just paused for a second, but you're back on. You're good.
All right. All right. Utilizing condition-based maintenance, right? It's out there. It's like the number one thing everyone talks about all the time. So we're talking about vibration, infrared, oil analysis, ultrasonic, motion amplification, electrical signature analysis. There's all different types, right?
Hey, Brian, you were frozen for a bit there, and it looks like your screen is not sharing.
Can you hear me?
We can hear you. Yeah, now I can.
Oh no.
There we go. Okay, now I see your slide again. Probably just some connectivity issues.
Yeah, I apologize. We've had lots and lots of rain and wind here recently. So I apologize, everybody.
Let's start from the beginning of slide 6.
Sure.
Or of this one. Yeah.
Yeah, sure. So again, everyone knows condition monitoring techniques. They're very, very popular. I think the most important thing with understanding condition-based maintenance is how does it impact the business? Where is it best leveraged? And then arguably the most important thing is that Ben is more important, in my opinion, is who you decide to partner with from a condition monitoring company standpoint than the solutions that they offer. I've said this at Reliable Plant, and I will keep saying it. There are so many companies out there that would love to sell you every sensor in the book, and then just there's no internal expertise to help you. Yeah, they can tell you something's vibrating, whatever, but they don't know how to connect it to the bigger picture in your team. Okay, so we need to make sure that we're looking at those benefits holistically. So vibration, infrared, oil, there's a million, like we said. The benefits of condition-based maintenance, right? We can increase equipment reliability, meaning to its design capacity. We can reduce maintenance costs. We can minimize downtime. We can optimize resource allocation. So the biggest thing for selecting, I'm not going to talk about specific technology, but condition-based maintenance in general is think about the cost benefit of performing maintenance, the risk associated with not performing maintenance, the risk associated with a person doing maintenance, i.e., confined spaces, working at heights, in poor atmospheres, right? So those are places we want to employ condition-based maintenance. So you have to look at risks. Is it more expensive for me to send a guy up there to potentially induce a failure or a failure mechanism, fooling with this thing, or could I put a pressure sensor on there and then we can just set up a routine schedule monthly or quarterly to where we check the sensor to make sure it's operating correctly, as opposed to sending somebody up there every couple of days to fool with something. So the context surrounding the utilization of condition-based maintenance is very, very important. There are a lot of companies, one in particular, that I trust wholeheartedly to talk to about condition-based maintenance and leverage their technology, and that is Uptime Solutions. I'm going to plug them. I have many friends that work with them. I trust them completely, and they are absolute crushers. So keep that in mind. They will not sell you snake oil. They will understand your business and get to the root of the problems, and then prescribe condition-based maintenance should it be necessary. So condition-based maintenance allows you to act on equipment needs before failure occurs. Yes, we want to be ahead. We want to say, hey, oh my God, this thing's experiencing an anomaly. Let's go take a look. But we don't want to associate the risk with sending humans to do risky things when we could have a sensor do those things. You still hear me? Everything okay?
Yep.
Okay.
Going smooth.
Yeah, I'm really sorry. I don't know what the heck happened there.
It's okay. Happens.
All right, let's go over here. Okay. Creating a feedback loop. So all the great work that we do in developing our preventive maintenance strategy, and all the work we do leading up to that, we want to make sure that we can document those things, understand what is working, what is not working, and then follow up with it. It's as simple as just the function of creating a corrective work order from a preventive maintenance practice, right? It's so simple. We got to know what we're doing right and how to address it and what we're doing wrong. And one recommendation I can make to you from experience is always, always, always think about the sunken cost fallacy. Just because you spent a whole bunch of money on something and someone else thinks it's the right thing to do, if the data and the people doing it say it is not doing what you said it was doing, stop doing it. I know it was expensive. I know, but you got to be a big boy or big girl at some point and say, hey, this ain't working. We need to adjust, because I promise you, the longer you let it go, the worse it will be. Okay. So continuous improvement process, document your maintenance outcomes. Of course, CMMS, paper, tablet, whatever, however you want to document it. We want to analyze the data we're getting from it. That's why we have failure codes or problem types. However you decide you want to associate a particular failure with something, a component, a part, a system, whatever. And then you refine your maintenance procedures based on that information. If you're doing a PM task so much and it's not generating any corrective work or any anomalies, why are you doing that task? Make sense? Okay. Track performance metrics. We want to plan, execute, analyze, and improve. You can't see the analyze part. It got cut off for some reason, but that's essentially what it is. We plan our work, we execute our work, we analyze our work. Did we do all the right things? Okay, sweet. What can we improve? Bang, we're going to improve it. Then we're going to put that into the new plan. Then we're going to execute it again. It is non-stop. Maintenance and reliability has no end. It's a journey. It's not like businesses get to the point where they're like, we're perfect. There's nothing else we can do. I haven't found it. If you found it, let me know. I'd love to talk to those people. All right. My favorite one, train and involve the team. Who are the stakeholders? Well, everybody in the company is a stakeholder, whether they know it or not, but we're going to touch on 4 of them. Maintenance technicians, biggest bang for your buck, maintenance technicians and maintenance supervisors. Supervisors have arguably the largest return when it comes to leadership training, planning and scheduling training, and technical competency, because they literally are driving the schedule day to day. They are the point of contact for technical expertise with the team. Equipment operators, huge one. Teach people how to use the machines and then solidify that with SOPs, and then involve them in your maintenance activities when you can. Give them an outlet to talk about the things they're experiencing with their machines, so that we as maintenance people can get that information and start changing those problems and eliminating those defects. Another one, the management team. Management team's a little harder to coach because we all have big egos and we know everything and we're all super important and too busy for everything, right? But at the end of the day, management needs to be put in check too, right? If you're a maintenance manager, you need to be active. You need to be up and out of your chair, driving the team forward, removing barriers, doing the right things. And you need to be building relationships with the other managers in your department or in your facility, EHS, quality, operations, all of those things. They got to be your best friend. We want to train each other. We want to learn from each other. We want to build relationships. Engineering staff's a huge one. Some companies do not employ an engineering staff, which I fully understand. I've been a part of that as well. But if you do have an engineering staff, you need to make them aware of the defects that you are having and the solutions you're implementing. And if they have any insight, or they can talk to the manufacturers who design and build your machines, so that when you do iterations, when you go to buy a new line, the newest version of the line, they don't sell you a line or a machine that has the same defects you had been fighting for the last 10 years. That's where engineering staff comes into play. So we can do a lot of ways. We can classroom train. We can do hands-on, which I prefer. We can do digital learning, right? Like Amissa had mentioned earlier about reliability access training, digital training, and then competency validation. If you train somebody something, have them show you. There's no shame in saying, hey man, great. We had a great class. Let's go out to the shop floor. Let's disassemble that bearing, or let's pull that snub shaft apart, or let's go pull that gearbox, that spare gearbox that's broken in the shop apart. We can get a look at how it functions, right? So always validate. A well-trained team is the most valuable asset in any preventive maintenance program. Bingo. People do everything. They achieve everything. I don't care about your AI and your technology, all that stuff. People do everything. Okay, go ahead, Amissa.
All right. I think this is the last question. So, how does your team identify root causes of reoccurring failures? We were talking about that a little bit earlier. Share your response in the chat.
Good one.
I want to compare the different approaches and share best practices here.
Yeah, I mean, as it pertains to preventive maintenance strategy, mine would be, we talk to the people who do the work and we understand the things that are actually plaguing them and happening. And then we analyze it from our different perspective. Okay. Five whys. Okay. Yeah. Hands on daily checks. EW was at end work orders. I don't know what that means.
I don't know what EWO stands for either.
Root cause analysis and feedback from site. Okay, good. Structured root cause analysis. Okay, fishbone
diagram.
Yep. We don't. Not enough people or time.
Yes. I mean, that's number one answer, I'm sure, from most.
Paul, be the change you wish to see in the world.
Easier said than done.
I've been there. I know. Okay, good. Lots of 5 whys.
Top set model. What's that? I actually haven't heard of that one. What's a top set model? Do you know?
I don't know. Quantitative. Yep. Pareto analysis is a good one. Yep, that's a good one. That's trends, right? That's grouping. Bad actors, RCAs, 5 whys. Yeah, a lot of 5 whys. Breakdown analysis. I think that's like kind of 5 whys too. Awesome. Okay. Ready to rip?
Yeah, let's go.
All right. Okay, last one. Monitor and review your performance, right? Kind of just like a feedback loop, but we're looking at it bigger now, right? What's the impact that we can actionably show for the business? And one of my favorites, if you guys follow our webinars, one of my favorites is the maintenance cost per unit produced. So if you're in manufacturing or you're making a product, how much of your maintenance budget does it take to produce one of those things? So this is essentially how it works is if your maintenance spend for the month is $50,000 and you produce 50,000 widgets in a month, that means that your maintenance cost per unit produced is $1. Does that make sense? It's super good at understanding cost-effective maintenance. Am I doing the right things from a cost perspective that's going to impact my product's cost, essentially, right? My maintenance relation to the product produced. Mean time between failure, you guys know what that. I'm not going to go crazy into that one. Mean time to repair, how long has it taken us to restore our machine? Okay, emergency work order, got it. Mean time to repair, how long does it take to restore our machines back to their function? Overall equipment effectiveness, right? That is your is a production and capacity analysis, right? It's a OEE, availability, performance, and quality. And then, of course, one of my other favorite ones is a long-term metric, which a lot of C-suite people who are spending the capital and writing those checks for machines and new things, they like to know, am I spending the appropriate amount of money to maintain this machine, right? And it's generally expressed as a maintenance cost as a percentage of your replacement asset value. So if we're spending $100,000 a year maintaining this press and a new press is $125,000, stop maintaining the press, buy a new press. Does that make sense? Super, super simple. So these are good ones. Maintenance cost per unit produced, MTBF, MTTR, OEE, and RAV. So the bottom one, maintenance cost is percentage of replacement. Everybody can do that. Doesn't matter what you're working on. You can actually understand that. How much am I spending on this thing? It doesn't matter if it's a truck, it's an excavator, it's a manufacturing line, it's a pump, it's a press, it's a compressor. You can do that. Overall equipment effectiveness is generally geared towards manufacturing, right? So if you're measuring quality, performance, and availability, you can do those things. Mean time to repair, anybody can do it. How long is it taking to restore function? Mean time between failure, anybody can do it. Doesn't matter what it is. What's the timeline between failures? And then maintenance cost per unit reduced is more towards production, manufacturing, things that you're, you're trying to manufacture and create. So you track the performance. Sometimes it can be difficult, but there are tools within your CMMSs and other things, other technologies that you can leverage that information. But you got to have the data. That's why we talked about all those things leading up to this, because this is what's going to, at the end of the day, is going to justify and certify that we're doing the right things or we're not doing the right things. Okay. What gets measured gets managed. I think everybody's heard that, right? Regular performance monitoring is essential for continuous improvement. Facts, right? Got to know where we are. so we can make good choices and do all the right things. Okay, what we got?
Okay, so we are at the Q&A section of the webinar. We do have about 15 minutes for that, so we will have time to answer most of the questions that come in. We already have a few. There was one earlier where someone was asking how to get the CMRP certification. I'll just touch on real quick while people are putting other questions in the chat. What I personally did, but there's a lot of ways to do it, which Brian can add some context to on other resources. But what I personally did is I took Reliability X, that's the name of the company. They have courses specifically on CMRP certification, and I took that course, and then I also read Ramesh Jalati's book called Maintenance and Reliability Best Practices, which I referenced in the chat. I think you can get it on Amazon. You probably like on Audible too, I'm sure. But those two resources, plus the help of my friend Brian here, I did have, I'm not going to say I didn't have, an expert connection, but he helped, and then I was able to get the certification. Now you get the actual certification through SMRP, which is the Society of Maintenance and Reliability Professionals. So you take the exam, you have to schedule the exam and go to like a college campus and it's like super legit, security and everything to take that exam. But you get your certification and schedule your exam through SMRP.
Yep. Yeah. 100%.
What do you have to add, Brian, as far as resources? I mean, that's what I use, but there's other resources out there.
Yeah. So I just recertified this month for my 4th time with SMRP for my CMRP. And when I first took the SMRP exam, the reliability, all that stuff didn't exist. So I had to rely on I was a director of maintenance and reliability at the time. So I had a lot of experience in the world, right, of maintenance and reliability. But I echo what Amissa said. So if you guys, I'm giving you a tidbit. Here is the key to success for your CMRP. If you are green in our industry, right? Or maybe you have some issues with some of the more technical things. This is the success. Everybody listen. I hope I don't see any. We got 112 people in here. Let's see if it drops. Read Maintenance and Reliability Best Practices by Ramesh Jalati, and then read Making Common Sense, Common Practice by Ron Moore, and then take Reliability X's online self-paced course, and then schedule your exam for 2 weeks or preferably sooner. You will pass the exam.
Oh, thanks, Nathan, for sharing that link. Nathan got his CMRP, right, Nathan? Through Reliability X courses, if I recall.
Yep. I think I had Nathan on the podcast, didn't I?
Yeah. That's what I remember.
Yep. So he did it. He did the magic. He did the magic formula there, and he got it. So I will say this. It's super important to make sure that you practice what you read, right? Especially if you're a practitioner. Now, I understand if you're not a practitioner, you just want to get lingo, you want to get the way that people talk, the language, all it's super important too. That's also very beneficial. But if you're a practitioner, it's nothing better than learning those things and applying them.
Yeah. Okay. Let's see here. So earlier in the chat, Sheldon had asked a question that I put in here. How do you manage planned maintenance quality and assurance, especially in large organizations with remote sites?
Hold on, let me pull that up.
Basically,
how do you
working interdepartmentally with other parts of the business across remote locations.
Sheldon, I guess it would what would determine a lot of that is how the maintenance organization is structured at each individual site, right? Is there a group of technicians that has a supervisor, and then is there a planner and scheduler and a maintenance manager at each site? Well, then it would be something different than if there's just one technician at a site and you have a maintenance leader who oversees all the sites remotely. Then it would be different. So it's going to be hard for me to answer that question, but managing planned maintenance is very easy. You have to develop the needs of the business. What are you going to do? Like we just talked about, right? Who is available to do it, the capacity and skill sets they have to do the work. And then how do you follow up with that work being done? So i.e. normally it'd be a supervisor or somebody to verify the quality of the work. So it's a hard question for me to answer, but you got to have checks and balances in place. So you need to leverage your organizational hierarchy. Who's there? Who does what? I would recommend that you create a RACI chart like we talked about and list out all those things you're talking about and who in your organization is going to be responsible, accountable, consulting, and informed for those individual tasks. That's my recommendation, not knowing the intricacies of what you're asking.
Okay. And then Paul, no mention of equipment criticality assessment. Any reason for that, as it is a good guide to where you need.
Am I frozen? Am I frozen?
No, I was frozen for a second.
My God. I think we touched on criticality in the very first section of the slide. Yes, asset, but we're talking, yeah, asset criticality is super important, right? Equipment criticality. So that's what we talked about risk base. When I mean equipment criticality assessment is if machines pose a great risk to your organization, whether from a production standpoint, a safety standpoint, a missed opportunity standpoint, a standby labor cost standpoint, they would be deemed critical, right? That's what I meant by that. And then for any reason for that, as it is a good guide to where you need manpower focus. Yeah, exactly. I thought we said something about it, but that's what I meant. The risk-based assessment of assets is what I meant by that.
Mm-hmm. Yeah, I thought you touched on it a little bit there. Okay. Electrical signature analysis versus conventional vibration analysis. Pros and cons.
So they are both great and they both have their pros and cons, but I don't pretend to know things. So this is what I would recommend. You need to seek out a gentleman by the name of Howard Penrose, the motor doc, and he will tell you every single thing with a PhD crisp on it of electrical signature analysis. He is the best motor and generator and electrical person I know, and probably there is. He also knows a lot about vibration, but if you are interested in learning more about conventional vibration analysis, you need to talk to somebody named Matthew Knuth with Uptime Solutions. They're the people. I'm not going to pretend to answer this and give you, I know a bit, but I don't want to speak on it. I'd rather have professionals speak on that.
Okay, let's see, what else do we got here? How do you, or how to encourage the technician and operator to report if any small defect identification in order to prevent the big defect?
When they do report something, act on it. 9 times out of 10, when operators report issues with their machines, nothing happens. So they stop reporting it and they take matters into their own hands to get production running. So the most important thing you can do, and I talked about this, and I think in one of our webinars, I think it was PM task creation. Yeah. Mm-hmm. The very first task of every single one of your PMs needs to be consult or talk to the operator to understand any issues, anomalies, defects in the starting, shutdown, or operation of this machine. So basically, you're sending a maintenance person over to the operator before they even touch the machine for an inspection or a PM, whatever. They walk over to that operator, they say, hey, man, or lady, what's going on with this thing? You notice anything goofy this morning when you started up? Has anything been happening? Have you had to make any adjustments? Have you had to do anything? Have any codes popped up? And then they tell you, you document them as corrective work order actions, and then you perform an inspection and bring them in on it and understand the issue, solve the problem. If you do something when they ask, they are more apt to tell you more about it. But if you don't do anything and there's no communication between maintenance and operations, expect nothing to get reported.
Yeah. Okay. Any chance, even in follow-up, that we can get a list of those books Brian mentioned? Paul, I shared my email address in the chat. So if you want to email me personally, I'm happy to send over a list of the resources. Yeah. And Janessa asked for the same thing. Could you list the other books and courses recommended, or possibly email them? So if you guys copy my email address there in the chat and email me, and then I'll connect you guys with the resources you are needing.
Yeah, I think Nathan posted them in here too.
Oh yeah, they're kind of sprinkled in the chat there.
Yeah.
And I know there were some other questions in the chat, so I'm going to scroll through and see what I can find. Let's see here.
Well, Ben asked, what's the spark to inspire a cultural mindset shift for maintenance? Well, Ben, unfortunately, it generally starts at leadership. Leadership has to want to have that engaged and forward thinking and questioning environment, right? So a lot of leaders want to be the boss.
Mm.
It's not a good way to be a leader, right?
Mm-hmm.
So if you're a leader and you start involving the team, you're going to hear things you don't want to hear. And that's good. We want to hear stuff that's not good because then it gives us the opportunity to correct it. So there's a double-edged sword here. If you make yourself available as a leader to drive cultural change and to get ownership and build accountability and all these things, you better be ready to hear things you don't want to hear, and then you better do something about it. Because if you go through the work of doing all that, and when people actually give you their honest and constructive feedback and you don't do anything about it, you're done. It's just as bad as being a maintenance manager who sits on his ass all day and directs from his office. That's jacked up. Don't be that guy. So you have to create the environment through your actions. Maintenance people, and all of you can attest to this, maintenance people are doers. They don't want to hear, oh, I do this, and they haven't seen you do a thing. You got to do it. You have to act. That would be my answer.
I have something to add on that too.
If you're not a leader, one second. If you're not a leader, then you got to be the change. You got to be the one to go to your team and say, hey, we got to come together here. We got to start. We're all losing. And I don't want to be a loser. We all need to come together and try to do the right things. Let's go talk to our boss together. Go ahead, Amissa. Sorry.
Yeah, no, it's cool. I think, what I was thinking about with this question is that Brian's right. Like, this all comes from leadership. However, we have a customer who was in a situation as a maintenance tech where the leadership was not in alignment, right, with this kind of cultural mindset shift. But he was that way. So we kind of call these people at Upkeep, we've coined the term of maintenance heroes, but he took it upon himself to be the change. So I see people saying, be the change in the chat. That's exactly what he did. He knew what needed to happen. And so he took upon himself to start making those changes. And then he was able to present that to leadership. And then they actually started making changes because he was making the changes. And then what happened with him? Well, he got a way bigger and better job offer somewhere else, or he was able to bring that maintenance hero mentality into his next career opportunity. So I think it's beneficial for the individual who can do that. It's beneficial for the leadership to be influenced by that individual. And then, of course, there's always going to be career opportunities associated with people who are like that, who take the initiative and decide to be the change. So I've seen it, and I've talked to some of our customers who have done that. So don't be afraid to be the person who makes a change.
Yeah. Oh, I think I just saw one here. Augustine, how do you improve maintenance and production partnership to look after the equipment? So it is very important for the maintenance leadership and the operational or production leadership to be best friends. You don't have to actually be best friends, but you have to have a mutual understanding of need. You need each other. Maintenance needs the operators to operate the machines to their capacity, to their function, so that money can be made for the business. And operations needs maintenance to ensure that those machines can perform that function through routine inspections, maintenance, and corrective repairs. So the best thing to do is to level set with the production leadership. Go to them, go to lunch, say, hey man, I know we're always at each other's throats. I know we have a lot of downtime. I know we have this, we have that. How can I help you? What can I do to help you? How do you view my department or the things that we're doing? How can I help? Take what they say and act on it. And in the same motion, you say, wonderful. Those are great things. I'm going to act on. I'm going to try to improve those things. I'd love for us to meet weekly or monthly or whatever it is, so we can keep up our improvements and provide each other feedback. But I also have an ask for you as well, production leader. Is there any way I can help you create SOPs for operating your machines so that they can be operated in a way that is most beneficial for their production capacity and ultimately the maintenance team? So many things, Augustine, are solved by a relationship, by just putting your ego aside or putting the daily fire aside for a minute and having an honest conversation with the people who are ultimately going to decide how that machine is operated. No sensor, no AI, none of those things are going to fix that problem. It's a relationship problem. I can't hear you. Am I gone?
Sorry, I was on mute. We only have about 5 minutes to go. So do you see any last questions you want to read off? I'm responding to some chats.
All right. So Amissa, Trent, you need to reach out to Amissa after this.
So I was just about to message Trent, but Trent, if you email me directly, I put my email in the chat, then I'm happy to assist you and make sure you get the support and help that you need. It's very important to us.
So we have a question here. As a maintenance leader, create a SOP is one of the most difficult things. Do you have suggestions? Get help. Ask for help. Talk to the people who you're writing the SOP for. Don't try to be a one-man hero. You got to get help. That's why we talk about bringing people into the process. If I'm writing an SOP I'll just use Augustine's example. Okay. We're having a bunch of startup issues. So production starts at 7 a.m. The maintenance team are fighting fires until 7, 8 o'clock because the machines are not set up correctly. Well, because we're doing structured maintenance and we're documenting our corrective work, we're going to know what failure mode or what issue or problem type is associated with the things that we're doing. I'm going to take that data that are pertaining to operator error or setup failures or setup errors. We're going to analyze them. And then I'm going to go to the operations leadership and say, hey, you and I both hate running around with our heads cut off every morning, but here are some things I've learned by analyzing the corrective work that we're performing. So let's get together or send one of your best operators or your line supervisor, or whatever, have them meet with me for an hour if it's okay with you, and help me write an SOP that we can both hand out to your team so that they can do these things correctly. Get help. Ask for help. We don't have all the answers. We don't know everything. We need help, especially from the people who are literally doing the thing you're trying to control.
All right. Well, we are at time. So thank you everybody very much for attending. I love seeing some of you are regulars at our webinars, and that warms my heart. And we always want to make sure that the webinars we're producing are helping you in some way, because at Upkeep, that is very important to us. And again, email me if you have any questions or need connections to any resources. I'm happy to, be the driver on that for you and make sure you get what you need. And then we hope to see you next time in the future.
Yes, thank you. Thank you so much. We love you. And the fact that you are here wanting to learn and educate is the first step.
Yes.
It's the first step. Seeking what you don't know. I mean, I learned stuff from myself talking, and Amissa talking. Like, I don't know everything. I'm just here talking head. But I love that we can give you little nuggets to take and actionably go and have conversations, start conversations, and do the right things, even if it's a little bit.
Yeah.
So we appreciate you just as much. Trust me.
Yeah. All right. Thank you all. See you later.
Thanks, guys. See ya.